Today we're going to look at solving mixture problems, and this is always a really big struggle for students, these mixture problems. They can be tough if you're not able to just set up a plan and execute that plan. So we have a chemist has two solutions of acid. One solution is 30% acid, the other is 50% acid. How many liters of each solution should be mixed to obtain 10 liters of a 40% acid solution? So we're mixing some things together, these different acid solutions. So here's what we have to organize. We got to figure out a way of organizing this information just as a starting point. So I know I have a 30% solution. I know I have a 50% solution, and I probably didn't have to write 0.3 or 0.5 or anything like that, but already doing it, so whatever. And then in the end, I want 40%. That's what I want in the end. That's what we want in the end, a 40% solution. So let's think first about the amount. What do we want? We want liters. So we're in liters here. So that's going to be one column. Another column is going to be the strength of the solution. So the percentage, how strong it is. And then let's just call this last column total. So for the 30% solution, we want to know how many liters should we put in, along with the 50% solution, how many liters should we put in order to obtain 10 liters in the end. We know that. That's the information given to us right here. Sorry, my zeros are looking weird right now. 10 liters. That's what we know what we want in the end. 10 liters of 40% solution. But I don't know how many liters of the 30, and I don't know how many liters of the 50. So here's what I have to do. I'm going to call 30x, because I don't know how many liters I'm going to put in there. If 30 is x, and I know I need 10, what does 50 have to be? 50 has to be the total minus x. Whatever x is, let's say it's 1 liter of 30%. How many liters of 50% solution would you need then to make up 10? 1 plus 9 is 10. What if it was 2 liters? 2 plus what is 10? 8. So this would be 8 then. So you're just trying to make up that difference. So if this is x, then this is going to be 10 minus x. So if this is x is equal to 4, this is going to be 6. If this is 7, this is 3, and so on. Okay, so now we have that. Strength is just going to be the percentage, so 30%, 50%, and put it as a decimal, and then 0.4. And then the total is doing liters times strength, so that will tell us the total value there. So 0.3 times x, 0.5 times 10 minus x, and 0.4 times 10. So we're just multiplying those columns together. Now we just set up an equation. I have, if I add this and this, that will get me that last piece of information. Whatever amount of the 30% plus whatever amount of the 50% solution will give me a 40% solution with 10 liters total. So I'm going to do 0.30x plus 0.5 times 10 minus x is equal to the total of 0.4 times 10. And from here, it's just solving. So once you can set this up, it is an equation that you need to solve. So I'm going to do 0.5 times 10. So 0.5 times 10 is 5 minus 0.5 times x equals 0.4 times 10 is 4. And then I see 0.3 minus 0.5. So I'm going to go ahead and take care of that. Minus 3. Did I say minus 3? 0.3 minus 0.5. I'm not sure if that's what I said. Negative 0.2 x plus 5 equal to 4. And then I also want to subtract 5 from here. Going a little bit quicker through the solving steps. 4 minus 5 is negative 1. Divide by negative 0.2. I'm right on my camera there. X equals negative 1 divided by negative 0.2 is 5. So I get x equals 5. The question wants to know how many liters of each. So if x equals 5, my 30% solution is 5 liters, because that was my x value. Then that means my 50% solution is also 5 liters, because it was 10 minus 5. So that's also going to be 5 liters. So since we got 5, it's 5 and 5 for both. Kind of a weird answer there, but it's still an answer. That's the foundational type of set. Like this table you can generate the same type of information for most problems in this same type of scenario. So let's look at the next one. It says a coffee shop blends 2 types of coffee beans. One type costs $8 per pound and the other costs $12 per pound. How many pounds of each type should be mixed to obtain 20 pounds of blend that costs $10 per pound? These problems, the biggest issue with these problems is just the overwhelming nature of them. Just a lot of words, a lot of numbers being thrown at us. So break it down. We have, well, let's just create a table. That's a good starting point. What we want is 20 pounds, so I'm just going to call this column pounds, of that costs $10. So we'll just call this column cost, I guess. So that it costs $10. Let's now piece together the other information. We have an $8 per pound and a $12 per pound. So we have an 8 per and a 12 per. And what we want is we want total to be 20. So that means how many of the 8 pounds? We don't know. So we're going to call that X. And then the 12 pounds, or yeah, the 12 per pound is going to be 20 minus X. Because I want 20 pounds total, and I don't know how much of each. So one of them is going to be called X, and that means the difference between that is going to be the rest. So the cost, this is 8, this is 12. That total column, total value of it, so it's going to be, if I have $8 per how many pounds, plus $12 for however many pounds I'll have, and then we'll have 20 pounds costing $10 per pound. We'll set up an equation, so 8x plus 12 times 20 minus x is equal to 20 times 10. Solving exercise, so 8x plus 12 times 20 is 240, minus 12x equals 20 times 10, and that gives us 200. See, an 8x minus 12x, that's a negative 4x, plus 240 equals 200, minus 240. So I get negative 4x equals 200 minus 240 is negative 40, divided by negative 4x equals 10. So what does that mean? X equals 10. That means we're going to have the $8 per pound, we're going to have 10 pounds of that. And then the $12 per pound, we are going to have 10 pounds of that also. So it worked out again. We just have to split it. But the setup doesn't matter. X is going to be whatever value you want it to be. And that difference is just going to be the $12 per pound. So good set of problems here. Tough problems on these mixture types of scenarios. But if you just understand this question, like understand one of these two, then you could extrapolate that to any sort of problem in this realm of these mixture problems where you're just setting up linear equations.